Right. Good to go?
Yep, go for it.
All right. Maybe some more people will trickle in as we go. Well, hello, everyone. I'm Ranger Dave here at Sleeping Bear Dunes National Lakeshore. And it's a beautiful day out, spring day out there today. I hope everybody has been enjoying this weather if you're in the area. And I'm, of course, part of the National Park Service. You can see our emblem here beside me. Our arrowhead symbol. It contains all the different things that we protect and educate people about in our different parks. And they all represent different things. We've got the bison down here, or buffalo, representing all the different animals that you can find in all our great national parks and national park sites. And we have a sequoia tree here beside me, representing, and some smaller little conifers next to it, representing all the plants that we have. This mountain beside me represents all the different landforms. And while we don't have mountains here in northern Michigan, we do have some towering sand dunes that we're pretty well known for. And a little bit of water here. It looks white on this picture, but this is supposed to represent all the water we have. And that's important for today's presentation. As you'll see, we've got plenty of water here in our watershed of the Great Lakes Basin. And last but not least, the arrowhead symbol itself, the shape here, is supposed to represent all the history and culture that is cherished in our national park sites and that we educate visitors about. So moving right along, first I'd like to talk about the National Park Service briefly and kind of zoom in on where we are in the country. This map is showing beside me all the different national park sites. There are 423 of them currently, spread all over the country. And you're probably more familiar with some of the big ones out west, Death Valley, Yellowstone, the Grand Canyon, or maybe some other big parks like the Everglades. But we are a national lakeshore, and there are hundreds of other non-national parks, national monuments, historic battlefields, and places like that, all over the place here. And we'll zoom in on Michigan. Here we are in northwest lower Michigan on the shore of Lake Michigan there. And we zoom in a little bit further, you'll see a more detailed map showing all the campgrounds, or both the campgrounds, and all the other different attractions that you can check out. We've got more than a dozen hiking trails. If you total up the lakeshore too, we've almost got 60 miles of coastline if you include the North and South Manitou Island here. And Manitou, in the Anishinaabe language of the Native Americans here, it means spirit. So these are the spirit islands. Okay, so I thought we should kick off with a couple-minute video that will give you some more details on what's in the park, kind of a flyby of all the different things you can do and see here. And without further ado, let's start this video. All right. Oops, let's skip that. There we go. And that'll bring us to the core of the presentation. What do you guys think of the video? Anybody want to chime in on something they noticed that they'd like to try sometime next time they come visit, or if they've already been here, something that jumped out as their favorite attraction at the park? Feel free to type it in the chat, and I'll keep glancing at that as we go here. Before we move on, I want to mention that there is an activity that's going to come up here in a little bit where we're going to make our own little watershed model, and you're going to need a piece of paper, preferably a waxy paper. I'm just going to use construction paper. It'll still work for our purposes, but if you have some kind of parchment paper, that's the best. And then just some kind of writing utensil. You can use some colored pencils or things like that. I'm just going to use a pen here today to draw my little town. And then the last thing you'll need is a little bit of water. Don't need a lot. I've just got a couple inches in the bottom here. Not too much. And of course, be careful if you're doing this next to a laptop or you're watching on some device. Careful with that water. Oh, love climbing the big dune. Those are probably referring to the dune climb there, Cecilia. Yes, that is got to be one of the most popular spots in the park. Did you go all the way to Lake Michigan, I wonder? The 2-mile hike or just up the main face there? A lot of people aren't prepared for that, and they think it's just Lake Michigan's right on the other side, and it's about 2 miles one way. So, all right, well, we'll jump right into the core of the presentation here. Again, watching our watersheds. So first, it might seem like an obvious statement, but we got to start here that water is essential for all life forms, all life as we know it, even if you go to Death Valley and some of the other driest places in the world, everything that lives there needs to get water somehow. They might not need as much of it, but they need to get it somehow. And take that all the way to other extremes, and even in the oceans, they need to get fresh water. Anything that lives there. If we look on different planets, even astronomers, biologists that are looking at possible extraterrestrial life, we're looking for water on places like Mars. As far as we know, everything needs it to live in some form. And this picture here beside me is one of the beautiful beaches we have here at Sleeping Bear Dunes. And that's, of course, Lake Michigan and the coastline there. And I point out real quick that this bluff here is not actually a dune. A lot of people think this whole thing's a dune. This is actually a glacial moraine left by the glaciers, and the dunes that we have are perched up on top here. We have some along the coast, some coastal dunes, but the ones that we're really known for with the big overlooks are actually perched dunes that are sitting way up on top of this gravelly leftover debris from the glaciers about 12,000 years ago. All right, but that's for another time, another program. Here's an image to show you, just to really drive home that point about water. Most of the planet is water, but as you might be able to guess, it's not drinkable. The vast majority, even though 70% or so of the Earth's surface is water, we can't use it in that form. And the Great Lakes region has about 20% of the whole world's fresh available surface water. So that's not including the glaciers and things that are tied up as ice. It's not including the groundwater that you have to dig down to get to, just the water that's on the surface and the lakes and streams and rivers. 20% of the whole world's water is here around us at Sleeping Bear Dunes and the Great Lakes. So it's a pretty precious resource that we shouldn't take for granted here. And even our own bodies are about 70% water by mass, which is kind of crazy. We're mostly water as humans. So what is a watershed? We should start there before we jump into the activity. The definition here you can see behind me is an area of land that water flows across or through. Remember, I mentioned groundwater on the previous slide. That's part of the watershed too, even if you can't see it and it's moving underground in a certain direction. And that depends on the boundaries of the watershed. And like I said there, it has to flow in that same general direction and eventually will collect into a body of water, such as a lake or an ocean, at the lowest point around. Ultimately, the oceans are sea level is the lowest point on the planet, with some exceptions like Death Valley and places below sea level. But for the most part, the oceans are the bottom. Okay, so moving with that definition, here's a diagram that shows what I'm talking about. This is a cross section of a river flowing along some mountains. And you can see that it starts with precipitation, whether that's in snow, in the form of snow or rain. Water makes its way down from the sky. And depending on the boundaries of your watershed, where it lands, gravity will take that water down to the lowest point. Excuse me, either whether it's getting absorbed, I'm blocking the absorption here, but it could be absorbed down into the groundwater here and eventually flow to the lowest point in the body of water you see there, which is a lake, or it's flowing over the surface, which is most of what we're going to see. Runoff from snow melt or from rainfall will eventually make its way into these little streams. The streams become rivers and bigger tributaries, but eventually all those rivers will make their way to either a lake or an ocean at the end. And that's basically the extent of a watershed. Some of it is evaporated out from the sun's rays, make its way back up and condenses as clouds, and then the cycle repeats itself. Transpiration, which it mentions here, is similar to evaporation through tree leaves and plants. As they're photosynthesizing, they're drawing water up through the roots, right? And transpiring it out into the air, where it, similar to water from evaporation, will make its way up to the clouds and fall again as precipitation. So that is all of that constitutes a watershed. So now with that said, I want to show you what that looks like on a map of North America here. All those arrows, there's a lot going on there, but all those arrows are showing the direction that water droplets would flow if they were to fall on that part of the continent. So you see those colored lines are the highest points around, and those define the boundaries of the different watersheds you see there. We call them continental divides. And here's the key here beside me shows you what they're all called. What do you think's going on with this brown one, by the way? You see this here over by California, Nevada, this brown lined one with the arrows all pointing there. Does anybody have a guess? What is going on with that watershed? It's not flowing to the ocean. Anybody? I'll keep explaining, but you can go ahead and type in the chat if you think you know what is going on with that one. But as you can see, the rest of them, eventually they're flowing either into like Hudson Bay up here in Canada. They're flowing, we'll zoom in on this one in a minute, but they're flowing out to the ocean through the St. Lawrence Seaway, the Mississippi River in this section here, or on the East Coast, just directly into the Atlantic Ocean through different rivers and tributaries. And on the West Coast, of course, or into the Pacific Ocean. So some of these boundaries are more, these continental divides are more obvious. The red line being the Great Rocky Mountains in the United States that continues this chain. Actually, it's called different things in different parts of the continents of North and South America, but it's all one continuous high point that continues all the way down to the tip of South America. But some are less obvious, like the pink bottom line here that is the southern boundary of the Great Lakes. Actually, when it goes by Chicago here through Wisconsin, it doesn't look like a mountainous area. It just happens to be the highest point around. So if water falls on this side of it, it goes to the Gulf of Mexico. If it falls, just over to the other side of that boundary, it's making its way to the Great Lakes and out to the Atlantic. So kind of cool. Oh, is that the Salton Sea? Somebody guessed the brown circle. It's actually, that's a good guess. Salton Sea is down here in that very southern point. So you're partly right. Yes, it's called the Great Basin. It's known as the Great Basin. And there is a national park in there in Nevada that I've been to called Great Basin National Park. And it's a pretty interesting area. There are other places like it in the world, but it's basically, and Death Valley's in there as well. And these are places that are surrounded by continental divides and high points, mountain chains, and they're bounded just so that all the water can't flow out to the ocean. It only seeps down into the ground or evaporates back up. And it's a pretty dry area because of the Sierra Nevada here, knocking out most of the precipitation. By the time any cloud systems get east of the Sierra, they are pretty dry. I've witnessed lone, sad little rain clouds moving along, and the rain evaporating before it even hits the ground is a pretty common sight to see in the Great Basin. So yeah, that's what's going on there. Great guess. All right, so now that you've seen the bigger picture here, let's zoom in a little bit. And we're going to look at the Great Lakes specifically, because that's pretty important to us here at Sleeping Bear Dunes. Okay, so here you have the 5 Great Lakes: Michigan, Huron, Superior, Erie, and Ontario. Lake Michigan and Huron are actually one massive lake. We kind of arbitrarily draw a divider right here at the Straits of Mackinac, where the Mackinac Bridge is, but it is all one continuous body of water. Excuse me, that's at the same level. And it looks like kind of a static lake system, right? You wouldn't think that it's flowing really, but actually Lake Superior is higher up in elevation than Huron in Michigan, Lakes Huron in Michigan, which is higher still than Lake Erie and much higher than Lake Ontario. And there is a pretty important point right here between Lake Erie and Ontario that you're probably familiar with, Niagara Falls. And, you know, so that's an obvious step down to Lake Ontario, but the same is true all the way up the system. So it's actually one large flowing system of water that makes its way out here on the east side, up the St. Lawrence Seaway, past Montreal, and out to the Atlantic Ocean. I've had people ask me before, is this water here left over from the glaciers? And which is kind of a funny thought, but I could see where they're getting that. Like initially, the water was left behind by the retreating glaciers, but that's been cycled out many, many, many times since then. And it's not, I mean, it's constantly being replaced by precipitation and runoff, but it is slowly making its way out to the Atlantic constantly. Okay. So now that we have a pretty good idea of what a watershed is, let's go ahead and make our own little model so we can have a better hands-on visualization. Go ahead and grab your piece of paper, move any expensive electronic equipment out of the way, or if you have a little pan or something you could put underneath, that would be even better. You're not going to need a lot of water. I want to emphasize that from the get-go. We don't want to flood our town here. So take your pen and your paper and just sketch a pretty simple little town. Some buildings, some trees, maybe some mountains, roads, things like that. Doesn't have to be too much detail, but just to picture a town from the air. If you were going to fly over some area, what would that town look like? And we'll spend a few minutes here. Let me set the mood with some nice little gentle waves breaking on the beach here behind me. Okay. And I am no artist myself, so don't worry about accuracy. It's not, I will not be grading your work, as long as you don't judge mine. Sure, you got some happy little trees. Maybe you can think up a little name for your town. I'm going to be original. Call mine Davetown. Population me. right. Starting to come together here. Here's my drawing so far. Look at that town with the lone mountain in the background. I'll give you guys another minute to finish up there before we do the fun part. Oh, it looks like we might have had some other people join. If you missed my intro, we are just drawing a little town. I'll hold mine up again. Doesn't have to be very detailed at all. We're going to make a watershed model here. So just put some little buildings, trees, well, whatever you want in your town. Maybe draw some rivers in too. I didn't draw any water. I didn't think of that. I'm going to draw a little pond now. Yeah. And then in a minute here, we will turn it into a 3D watershed, just like that. My rain stopped playing. I clicked on, there we go. This is a pretty peaceful day in the park, I should say. Usually the waves are breaking a little bit harder than that. We get pretty constant wind here, hence the dunes that we have. Wouldn't have them if we didn't have the constant westerly wind. Okay. I think that's a good enough amount of time for the sketch. Let's jump over to the next slide, but take your paper first here. I would like you to crumple it up, not too dramatically. You don't want to make it like a tight little ball. Just kind of loosely crumple your paper. Like so. And then unravel it. And you should have some peaks and valleys now. You see that? Yeah. So hopefully yours looks something like that. Set it in front of you here. Now take your little bit of water and dip your fingers in. Just get the fingertips wet and make it rain. Your hand's a little cloud now. Run it over your watershed and have it sprinkle around. Notice where the water goes. Where's gravity taking that water? Some of mine's soaking through. That's all right. We need some groundwater in our watershed too. But hopefully you'll see, like on mine, some of it's running down. And you probably have multiple watersheds, I should say. Anywhere that is bounded by some high points, the highest points around, those are going to be their own watersheds. And they might flow out of that watershed into neighboring bodies of water. There we go. Nice little happy sprinkle over your town. Everybody seeing that? Usually I'd have you hold up your models here, but I can't. I'm just going to have to imagine how pretty your town looks. There you go. I've got some lakes that are over here and kind of puddled up on this low side over here. Yeah, so that might help you visualize a little bit more what we mean when we talk about a watershed. Okay, so hope you had fun with that quick activity. We're going to jump for the sake of time. I won't spend too much time on these last slides here, but we want to talk about some issues that are facing our watershed, specifically here in the Great Lakes. They're getting kind of stressed, and this has been something that's been building for a while. This is a kind of a recent map here that's trying to show cumulative stress, which is all the different factors that could be stressing out the watershed. And the dark blue stands for low on the scale up here, and all the way up to dark red for a lot of stress. What are some things you guys think that could be stressing out this watershed? And follow-up question, where do you notice most of that stress happening? I'll give you a minute. If anybody wants to chime in the chat, what do you think could be some reasons our Great Lakes are stressed out? Anybody? Oh, I see. There's the Q&A too. The edges are more stressed. Yes, good point. The middle of the lakes, not so much. Here we go, the middle of the lakes. More so around the coast, and that's where the cities are. Yes, it's no coincidence. Places like Chicago, Milwaukee, Green Bay, even Traverse City here near the park. These are the sources of a lot of stress, of the human activity. I saw some other great comments here. Invasive species. Yes, Cheryl, that's a big one. And here is a little model to show you some of the ones that are plaguing our Great Lakes in the nearshore areas of Lake Michigan. All the Great Lakes really are these round gobies, which are native to Eastern Europe, places like the Black and Caspian Sea. And they've made their way here in the ballast water of large ships that made across the Atlantic. And what's around them, you might see here, and you probably are familiar with if you've ever visited the Great Lakes anytime in the last couple decades, are zebra mussels, and their more recently arrived relatives, the quagga mussels. And this is pretty much what the lake bottom looks like over vast areas of the Great Lakes, including Lake Michigan right now. And that is definitely stressing out the native species that are there. It's disrupting the food web and all sorts of other issues. It's really clogs up water intake pipes. The mussels grow really in these tightly packed areas, and that can disrupt things. Anybody else had any? I fished out some zebra mussels the other day. Good, a few down. Yes, not enough time for the water to recharge. That's a great one too. Great comment there from somebody. There's some others, more classic stressors would be some runoff, pollutants, overuse of fertilizers, things like that. Those can cause dead zones with no oxygen. And you can see Lake Superior is doing better, but it's still got some stress going on around its edge. Bigger doesn't mean you're immune to those effects. And then poor Lake Ontario down here is very stressed out. It's partly because it's at the end of the chain. Everything's flowing into it. Some bigger cities around it. Yeah, so for the sake of time, I'm going to move on. Great observations here. And this is just a diagram trying to show you how it's happening. It's a lot of little things. It's not always these big spills that get publicity. If there's some kind of an oil spill, pipeline break, those are pretty obvious and big ones. But often a lot of it is just simply litter from garbage cans overflowing, making its way down. Eventually, every little piece will get blown by the wind, by runoff from the rain into storm drains, and it makes its way into our streams and ultimately out to the oceans. It's no coincidence that the oceans are building up in the plastic, because everything's eventually, unless you're in the Great Basin, making its way to the ocean. So it's not just the big spills; it's all the little issues we have here with waste, proper waste disposal, and litter. Yeah, so this is how it can happen. And that is actually the end of the program. We're coming up on 3:30 here. I wanted to plug our distance learning programs at the end. This is kind of a shortened version of one of our traditional programs. And if you've liked what you've seen, check us out. I put a link in our resources tab in our virtual booth. So please check that out. Arrange a program with us. We'd be happy to teach you about different things like our black bears, the Anishinaabe, which again, the Native Americans of the region, and other great topics, piping plover, some endangered shorebirds, and the list goes on. So thank you guys so much for joining. And to open up to questions, there's only a minute left here, but I did see somebody, what's stressing Escanaba since quite away from the big cities? Good question. I'm not entirely sure. I know it's not a big town, but could be some agriculture going on there that is causing some stress, but I'm not entirely positive on that one, but good question. Anybody else?
Yeah, we had one other question from the Facebook Live. Could the watershed direction be reversed at the Atlantic Ocean, creating a brackish water in the Great Lakes? Or that?
Yeah, that's a great question. It would be pretty tricky to reverse Niagara Falls. It's a big hurdle. But there was something that made me think of is that one time the water was flowing into was cut off from the Mississippi, but when Chicago got big enough, they actually had to drain the water. The sorry to gross you out, but sewage, all the pollution from the city started to build up in Lake Michigan, and they had to drain it out to the Mississippi. So they actually kind of reversed the water flow, dredged out an area going to connect to the Mississippi so that they could drain water out that way. So it is possible to reverse the course of a watershed if it's level enough that you don't have to do too much work. Again, Niagara, it'd be really a challenge to turn the Great Lakes system around because it's such a big height difference. Not even just Niagara Falls, going up to Lake Superior is a pretty big jump in elevation. So a good question. Anybody else when we're wrapping it up here? Thank you guys for your participation. I really appreciate all the thoughtful questions. And yeah, we hope to hear from you guys. If again, reach out to your teachers to arrange a program with us. We try to keep it to a minimum of about 5 students. So even if you're homeschooling or have some kids you want to get involved, just link up with another group and we'll try to get you on our calendar.
Yeah, thank you.
Thank you so much, Hazel. Appreciate the moderation.
Yeah.
Thank you, Cecilia and Jonathan. Appreciate your time. Take care, everybody. Enjoy the rest of SciFest.
Bye.
Bye.